Alright, so now we're gonna get into the advanced storage example of this bootcamp. So advanced storage is basically you take the concept, a lot of concept from a simple storage, and now we're gonna add a lot more advanced concept into it. Things like access, like control, if errors, those ones, especially a couple like unique features and I haven't explained before, and use those one for to see more advanced example of using Solidity building applications. So let's go. We're gonna use Remix for this example. So let's go over to Remix. You can follow along on the Remix. Just follow code along, or you just go through the code example right here with all the comments. All right. So let's go to Remix. What you do, you're gonna add in a new file called advanced storage.sol. Alright, and now let's start typing. Alright, so first thing, remember, always start with the license identifier, and gonna use MIT. Now you have pragma. Alright, Solidity, and let's just do 0.820. Alright, just anything over 20. And now let's go for contract advanced storage. Okay. Let's see, what is this? I think it's just like some weird linting SPDI. Oh, okay, I see why. Cause okay, there you go. Just a little bit typing, a little bit typo. All right, so for this advanced storage example, we're gonna do something like a vault concept, and with like a manager, with people who manage these things, right? So first, let's declare an address to be the vault manager, right? So vault manager, right? And then what next we're gonna do is I want to declare a struct that represent an investment vault, right? It's a vault manager. There's an investment vault that this vault manager that manages, right? So let's do a struct. Oops, sorry, my typo. Investment vault. All right. So you have now. Let's do UN 256 investment duration. All right. So for investment, you need duration of it. In 256, you want return on investment. All right. Boolean. All right. If the initialize, right, and is the investment vault has been initialized, you have address, right, identity card, which is like the identity card of the related to the investment vault, right? All right, so next one we are going to so before we go to the next step, I want to introduce a concept of constructor to you guys. All right, constructor is essentially a function that runs when the contract is initialized on chain. Essentially, once you create a contract, this is the first function that's gonna run, essentially, right? So in this case, we're gonna do vault manager equal to message sender, right? So essentially, essentially this one means that anyone who creates this contract will be the vault manager, right? If you create the advanced storage contract, you will be the vault manager automatically. Message sender is basically means that the person that send the transaction, right? Message.sender. It's a global variable. You can have access everywhere inside Solidify, and is basically means whoever sent the transactions. So then in this case, we assign that person to become the vault manager, which is and it's in the constructor. That means this is the first thing it runs. So essentially, when you create a contract, that person will be assigned as the vault manager. All right. So the next one. So we're gonna do this one. So we are going to declare vault private investment vault. So you declare a variable with the investment vault type. So with the struct, this struct type, right? Now, next one is we are going to create a function, right? To set initial investment vault, right? And then this is UN 256 days after, right? We're gonna go over some of this. 6 return on investment, right? And address vault owner, right? So it's the owner of the vault, right? Public. All right. So now we want to make sure that only message sender is gonna be the message sender, the function, the person that calls this function, it has to be the vault manager, right? So we're gonna do a if statement right here, right? If message sender, so whoever is calling this contract, not equal to vault manager, right? And you would revert, right? You would revert. And this is where you would declare a error, an error class right here. Let's go here, error, ownable, unauthorized account, right? And then you're gonna return address account as calling, right? So I return, what is being called essentially. And then you're gonna go to your revert statement, ownable, unauthorized account, right? And then you're gonna put in the message sender right here. So essentially what it's doing right here is gonna check if the person calling this function is a vault manager. If it's not, it's gonna remove on every single effect that has happened. That's the thing about revert. So essentially, even you have code above the revert, it will still revert everything back to initial state. Right. Now, next one you do is you're gonna declare the investment durations. Right. So you're gonna declare this investment duration. So we're gonna have a local variable, block.timestamp, right, plus days after times 1 days. Right. So basically you asking people to input how many days after for you to essentially for investment duration. Let's say today is like the 1st of January, right? So I want to be 30 days after, and so that's going to be the investment durations. Okay, now next one, what we're gonna do is we want to create an identity card, right? So we have up over right here identity card. So now we want to create a identity card for the customer. So we're gonna achieve this by doing another contract. Let's go to this one. Let's do another contract. Give me one moment. Let's do another contract. All right, so let's go down and just me. Contract. All right. Customer identity card. All right. And here you can have address, public, customer. All right. So you have a variable called customer. You can have a state variable called customer, and then you can do constructor, right? And then this constructor is gonna take an address and it's gonna be customer. So you're gonna have to pass when you create the contract. What you need to do is you have to pass in an address to specify this is the customer, right? And then it's going to be assigned to this customer, right? So there you go. So you have the one of this. Now you go back up into this part. So now we're going to create an identity card for this customer. Identity card, customer identity card equal to, and then you're gonna do it's a new. You use the keyword new, customer identity card, right? And then it's gonna pass in vault owner. Right, this is how you create. So you're gonna pass in the customer identity card, and that's gonna be assigned to the address of the vault owner. As that's the input you get right here. The next thing is you're gonna assign the address, investment vault equal to investment vault, and then you're gonna do that syntax where you do investment duration equal to this assigned to be investment duration. You gotta do return on investment to be equal to return on investment, and initialize. You're gonna say true. Give me one moment. And identity card to be that's gonna be this syntax, customer identity card. Alright, so this is a unique syntax. Okay, let's go over this one. Oh, I need to close this one. Yeah. So essentially here, I'm gonna assign investment vault right here. Alright, this the value to have and add into the struct, right? So this you have a variable as private that has a type investment vault, which is a struct right here. And then you're gonna pass in the information. You have the investment duration that you get right here, and then you can put return investment. That is inside the input. You're gonna switch initialize into true. Identity card. You're gonna pass in the customer identity card right here. Right. This is what you initialize, the customer identity card. But then you're gonna use the syntax called address. Address bracket, and you have the contract inside. It's gonna return the address of this contract, and that's going to be the address of the identity card, right? So where the address where you can find the identity card. Cool. So that's the function for you to create a new to set initial investment vault. So now let's have a function to edit return on investment, right? In 256, you're gonna obtain a new return on investment. You get some new number, get in public. Now we're gonna change it up a little bit. We can use require here. All right, so message sender equal to vault manager. All right, so you can see the effect. It's gonna do the exactly same thing as the other one, except it's a slightly cleaner syntax. That's it, but it does cost more gas though. So. And then you have investment vault dot return on investment. All right, go to new return on investment. All right. There you go. So you can edit the return on investment of this vault. And next one, we're gonna do is we're gonna retrieve. We need to get the the customer investment vault. So you do retrieve investment vault, right? Public view returns, and then you're gonna have investment vault memory and investment vault, right? So like this. So this is just essentially what it does is just it's a standby variable for you to return, right? And return investment vault. You return the private variable that you has declared before, and we're gonna have another function to retrieve customer information, right? Information, right here, public view return. So it's just a syntax, and you return the address, right? That's the type that you're returning. Turn. So you have customer identity card. All right. So it's gonna be very, very specific. So in the first thing, you're gonna initialize. Remember the syntax. So you take the type of the contract. So essentially the contract, you're gonna pass in the address of that contract. So in this case, it's investment vault dot identity card, right? Because we pass in identity card up here to be an address of the customer identity card. So you have the address right here, and you pass it in to initialize the instance of the contract. And now you're gonna go in and call the method customer. And does this method comes from? Customer right here, which is this one. Because when you declare a variable with the visibility public, what it's gonna do is it's gonna create a getter function with the same name with this variable. It's gonna be customer. So you can call this, and that's gonna return you the address of the customer. Right. There you go. So that's how the logic, that's how you assemble this advanced storage contract. So now let's compile it and let's try it out, right? So you can compile it, works. Then you go to this part, you gonna deploy it, right? So advanced storage contract, and you need address of, so you remember the constructor, right? It's right here is the message.sender, so it doesn't require any input. So you can just click deploy. So now this one. So now you check your vault manager is 0x5b something to DDC4, right? Which is this one. So 0x5b DDC4. So that's you. You create a contract, so you are the vault manager, right? So you retrieve everything is initial value, the initial default values, because you haven't done anything, right? You haven't set initial vault just yet. So let's set initial vault, right? Let's say for initially, you want the, it's going to be 30 days after. Turn investment is going to be 10. Vault owner is going to be, I don't know, like let's do some other address you have right here. All right, so that's another, you can select on, you have 10 addresses over there to select. So that's the vault owner. All right, let's transact. It works. So now it works there. So now if you do retrieve customer informations, you can see this right here. All right, retrieve investment vaults, you see the information. All right, so you have all this thing. Now you have the address of the customer as well. All right, and also here you also have the investment vault. So everything works. So let's say I want to change the return on investment. This one I had it to be 10, right? So let's do 20, right? Let's do transact, and now investment vault is changed to 20 right here. Right? And customer information, everything's the same. Use the vault manager. So yeah, so that's basically how you would use Solidity in more advanced use cases with more, like custom error class, ownable unauthorized account, require message using the keyword new, and like calling different, for calling a function from another contract with another contract. So yeah, thank you so much.